Hello and welcome to everyone. I am Deep. Today in this video session we'll be learning about VPC endpoints. We'll be further looking into how we will be using VPC endpoints to assist the RDS API calls in the AWS. So let's first see what VPC endpoints are. So in AWS, a VPC endpoint is a connection enabling system, or we can say platform, that enables connection between a virtual private cloud and supported services without requiring that you use an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. Therefore, your VPC is not exposed to the public internet. So VPC endpoints are of three types. The first one is interface endpoint. So an interface endpoint uses elastic network interfaces as its gateway to serve traffic to the destined AWS services. And the second one is the gateway load balancer endpoints. So the gateway load balancer endpoint is a type of endpoint that uses a route table for routing the specific traffic to the AWS services. So it serves as an entry point to intercept traffic and route it to a network or security service that you have configured using the gateway load balancer. So you specify a gateway load balancer endpoint as a target for a route in a route table. And the third one is gateway endpoint. So gateway endpoint is also a type of a VPC endpoint that uses route table. So to just destine the traffic to the required AWS service. So gateway endpoints are specifically meant for Amazon S3 and DynamoDB. So these are the three main VPC endpoints. So the main gist of using the AWS VPC endpoint is to avoid exposing the AWS servers hosted on the private subnet, or we can say private network, to the internet. And without exposing those servers or services to the internet also, we can perform the different AWS API calls on them to perform the specified actions. So talking about in the real world scenario, mostly the databases are hosted on the private subnet, or we can say private network, as they contain sensitive data and are not meant to be exposed to the internet. Thus, to perform any sort of actions on their databases, such as the actions can be related to creating databases or modifying the database, we need to expose it to the internet. And let's say that if a hacker or a bad thing is waiting out for their database server to be exposed onto the network or onto the internet, public internet, and do something wrong on that, then that would be just a bad choice. Thus, for this, we can use the VPC endpoints to securely connect or perform the API calls on the AWS RDS or any sort of other services related to AWS without exposing it to the internet. So further on this real-time demonstration, we'll be looking into how we use VPC endpoints to perform different API calls using a private hosted EC2 server on AWS RDS services. So here the EC2 instance will be having no internet connection, and using that privately hosted or EC2 instance that will be hosted on the private subnet, and will be using that as a gateway to assist or perform the AWS API calls on the RDS service. So let's see this demonstration in real time. So this is the architecture diagram that we'll be working on this demonstration. So we'll be working on the periphery of this architecture diagram. So let me quickly explain the overall scenario of this architecture diagram. So we'll have a virtual private cloud, and inside that virtual private cloud we'll be hosting two EC2 instances. One EC2 instances will work as a bastion host that will be hosted in the public subnet, and another will be using the private subnet. We'll be hosting that one into the private subnet, and that Amazon EC2 instance will be acting as a private server. So one EC2 instance will be having public access to the internet through the internet gateway, and another EC2 instance will not have any sort of internet connections, and that will be hosted in the private subnet. And using that Amazon EC2 hosted private subnet EC2 instance, We'll be using the VPC endpoint in place and perform the AWS API calls on the RDS service to create RDS, or we can say to modify RDS, and see how the VPC endpoint works in the real world scenario. So hope this architecture makes sense at your end. So let's move ahead with the steps that we'll be performing in this demonstration. Okay, so these are the easy to follow steps. So we'll be moving one by one so that it makes sense and it is easier on your side to understand. So the first one is the VPC part. So in the VPC part, first we'll be creating a VPC with this CIDR block, that is 10.0.0.0/16. So let's create that one first. So let me go to my AWS management console right now. Okay, so this is my Amazon EC2 RDS EC2 console. So I'll click on instances. Okay, let me first go to VPC, as I haven't created any sort of VPCs right now. I'll open it in another tab and I'll click on VPC, and as you can see that I currently have one VPC that is the default VPC. As you can see that the default VPC option is been checked or written as S. So this is the default VPC. We'll be creating a new VPC over here. We'll click on create VPC, give it a name. Let's give it a name demo VPC, and the CIDR block was 10.0.0.0/16. You can just recheck that if the CIDR block is okay with this or not. Yeah, that's perfect. And yeah, we'll leave all the options as default and click on create VPC, and we can see that our VPC has been created. Now the second step is to create two private subnets with this IP ranges and two public subnets. So we'll be doing that one quickly. I'll be on subnets. I'll click on, as you can see, these all are the default subnets that are associated to the default VPC. We'll click creating on, we'll click and choose our demo VPC, as we want to create subnets for my demo VPC. I'll give it a name. Let's give it a name public subnet 1. Availability zone, we can randomly choose any sort of availability zone, but we'll be choosing 1A and US East 1B VPC availability zone. So we'll be choosing 1A/24. Let's check it that, yeah, it's 24. And we'll click again and add a new subnet. I'll give it a name it a public subnet 1 before, and now it's public subnet 2, availability zone US East 1B, and the IP range will be 10.0.0.1.0/24. And similarly we'll be creating two more subnets for the private subnet, and I'll be naming it as private subnet 1. I'll be choosing the availability zone as the same one, that says US East 1A for this, and give it a IPv4 CIDR block, that is 10.0.1.0/24. And similarly I'll be creating another one, that is the last VPC, that says private subnet 2, availability zone US East 1B, and 10.0.2.0/24. And we can see that I have created two public subnets and two private subnets. Okay, let me do that one, and yeah, now that is perfect. And I'll be clicking on create subnet, and once I click on create subnet, my all of the 4 subnets are being created, and we can see that there are 2 public subnets and two private subnets. Okay. Now let's move to the next step that says we'll be creating two route tables, that is public route table and private route table. Let's do that. I'll go on route table. I'll click on create route table. I'll name it demo RT, that stands for route table, and this is meant for my demo VPC. I'll be choosing that one and click on create route table. And as it was meant that we'll be creating two route tables, let me rename it as public demo RT, and I'll be creating another route table that says private RT, as it's meant for the private routing, and I'll be choosing the same VPC of mine and create route table. And we can see that we have created two route tables. One is meant for public hosting or public EC2 instances, and one is meant for the private demo or private EC2 instances or private RDS instances. So our two route tables has also been completed successfully, and now we'll be creating one internet gateway and attach it to the public route table, as internet gateway will be used as for the purpose of attaching the bastion host so that we can be able to connect to the private EC2 instance. So let's do that real quickly. I'll go on internet gateway, click on create internet gateway, name it as demo IZW, click on create internet gateway and attach it to the VPC of mine and click on attach internet gateway, and my internet gateway has been attached to my VPC. And yes, now let's go to route table and let's assign the respective subnets to the respective route table. So I'll go on my public demo route table. I'll scroll my screen a little up, go to subnet associations and click on edit subnet association. As this route table is meant for the public routing purpose, so we'll be choosing the public subnets only, that is public subnet 1 and public subnet 2, and click on save association. As this route table is meant for routing the traffic to the internet, thus we'll be assigning the internet gateway that we have previously created. So let me click on public demo RT, I'll click on route and I'll click on edit routes and add the destination, that is internet, that is 0.0.0.0/0, and the target is internet gateway. I click my gateway that I have previously created and click save. This simply means that any sort of EC2 instances or RDS instances associated with this route table will be able to connect to the internet. So this public route table is meant for the internet connectivity and the private route table is not meant for the internet connectivity. Thus we will be not assigning any sort of internet gateway or NAT gateway to it. So I'll have to associate the subnets. So I click on subnet of the private route table and select the private subnet 1 and private subnet 2 and click on save associations. Looks perfect. So let's see till now what we have done. So till now we have completed all the VPC part. That is, we have created a VPC, we have created two private and public subnets, we have created two route tables, one is for public routing, one is for private routing, and we have created one internet gateway and have attached it to the public route table. Okay, seems cool, and let's move ahead with the EC2 part. So in the EC2 part, we will be creating two EC2 instances, one as a public instance and one as a private instance. So let's do that real quickly. I'll go to my EC2 dashboard, I'll click on this one, and we can currently see that there are no running instances right now. I'll click on launch instance. I'll be choosing Ubuntu. Let's choose the Ubuntu server 20.04 LTS. I'll select that one, and Yeah, I'll be choosing the free tier. And the most important option or things to be remembered while creating the EC2 instances in a custom VPC is over here. That is in the step 3 of creating it. That says configure instances. So in the network part, we will be selecting the demo VPC that we have created. That is our custom VPC. We'll be selecting that. And it will provide us with the subnets that we have created previously. So if we scroll it down, or click on that, we will be shown 4 options or 4 subnets that we have created. The first one is, so as we are meant for creating this EC2 server as a bastion host or jump box, so we'll be opening or creating this within a public subnet, because our public subnet 1 and public subnet 2 are associated with the public route table, and the public route table is being associated or being routed to the internet gateway. So in a case, if we create a EC2 instance using the public subnet 1 and public subnet 2, we'll be able to connect to the internet. So I'll be choosing the public subnet 1, and auto assign public IP, I want to enable it. And everything looks good, so there is nothing we need to do over here, and we'll click on add storage. That is perfect. And add a tag. Let's name it as jump server. So we'll be using this server as a jump box for our private server. Click on next, and let's create a new security group. Bastion host security group, and SSH, yes, that one is perfect. And for that I'll be using my IP. Click on review, and everything looks cool. I'll click on launch, and I'll be choosing the existing key pair. I'll acknowledge it and launch it, and our bastion host in the public subnet is being created. Click on view instances, and once it is in a state of pending and being created, we'll be creating the private subnet EC2 instance also that will be hosting it on the private subnet. I click on that one. Again, we'll be choosing the Ubuntu OS. We'll be choosing the same configurations. Same one. Over here we'll be choosing the demo VPC. Over here we'll be choosing the private subnet 1, and we don't want to auto assign the public IP over here, so it is disabled by default. We'll be choosing the add storage. That is perfect. We'll be adding the tag. Let's name it as demo private server. And click on next, and let's create a new security group for it also. Demo private server SG, and yes, the SSH is my IP, and we'll be just configuring other security options later. I'll click on launch and choose the existing key and click on launch instances, and this is also in the state of creating. So we have created 2 EC2 instances, one in the public subnet that has the public IP address that has the access to the internet, and another one that doesn't have the public IP address but has the private IP, and it does not has any sort of connectivity to the external network, or we can say public network. So we'll be checking that in a minute. So as it's in the initializing state, and once it comes up, and we'll be moving ahead with the other further steps. So let's see what we have done. So we have created VPC, that's done. In the EC2 part, we have created 2 EC2 instances, that is also done. We have created one public and one private instance. Now once that is created, we'll be moving with the major one, that is creating the VPC endpoints. But before we move into the VPC endpoint, we will be checking this into real time if there is internet connectivity on the public instance side and the private instance side. So let's log in into each of them. First, these are the EC2 instances. Let me grab their IP address, the IP address of the jump server that is having the public IP and has the access to the internet. I'll go to downloads where my key is there, and okay, this is the command, this is my PEM key, and I'll paste my public IP. And once I click on that, we can see that we are connected to the public EC2 instance. And if I check over here, I'll ping to the Google server, and we can see that we are successfully pinging. This simply means that our public jump EC2 instance is being connected to the internet and has the access to the external internet. That's why it's pinging to the Google server. I'll cancel that one, and let's use this server to connect to the private EC2 instance. And so we'll be needing the key over here. So let's open the key over here. The key is, it was inside my download folders. This is the key contents. Copy the contents. Let me create the same PEM file over here in the public subnet, so that using that key we can just logging into the private subnet, as we cannot log in into the private EC2 instances directly without using the bastion host or the jump boxes. So for that purpose we have used the bastion host over here. And we'll click on Ubuntu, no, sudo. First we have to create that key over here, sudo nano paste the contents over here, Control X, and now if we ls it, we can see that the same key related to the private EC2 instance has been present over here. Now SSH, let's SSH into it. First we have to modify its permission, that is ch mod 400 and the key name. It's been modified now, and once our permission is changed, we will be using the command to SSH into it, that is sudo ssh-i, then the key name and the server name or server OS name, and click on choose the private IP of the private server, that is 10.0.0. You can copy from here and paste it over here. And as you can see that I'm logged in into as a private server, into my private server, that is 10.0.2.81, and you can verify it from here, that says 10.0.2.81. that is the private IP of my demo private server. Okay, looks perfect. Now let's see if there is an internet connection into my private server or not. We can see that I'm not able to ping to the Google server, as I have not been connected with any sort of NAT gateway to connect my private EC2 instance to the external network, or we can say to the public network. So we are perfect to use the VPC endpoints. And let's click on Control C. Okay, so now the next step is to use the VPC endpoints or to perform different sort of API calls to the RDS. We need to create an IAM user and assign that IAM user the required roles for assessing or for performing the RDS related API calls in the AWS. So let's do that real quick. Let me go to my IAM console, click on IAM, and once I go over here, I can click on users, click add users. You can give any sort of name like demo test, click on SS keys, programmatic SS, as we don't need any sort of password based AWS management console SS. We'll choose SS key and programmatic SS, click on next. We need to provide it at the existing policies directly, so you can provide, as we are performing this demonstration for the RDS purpose, so we'll be choosing RDS and we'll be providing the RDS full SS. You click on next, we can click on tags and you can click on review and get user. And once you create a user, you'll be given the key. We can download it, the SS key ID and the secret SS key ID, and it's always a good idea to download it before we close it because it's sort of a one-time password, and once I click on close it will be vanishing, so we'll not be able to regenerate it again. So the best option is to download it once that's done. Okay, so I'll open that one and I'll need to configure my private server to be able to assess or perform the RDS related actions at my end. So I'll be needing to provide the SS key ID and secret SS key ID, so the private server has access to the RDS server or RDS API calls. So I'll go on my server, private server, I'll click on AWS configure and I'll be configuring my, okay, it says that the AWS CLI is not installed. I'll need to install it, sudo apt install AWS CLI. I think I need to update my server once, sudo apt update. Okay, as it says that I don't have the internet connection, so I'll not be able to update my server and I'll not be able to install any sort of external applications onto my private server as I don't have internet access. So for a while we can create a NAT gateway over here and just access to the internet, and once we have just come up with the installation part of the AWS CLI, then we can just deattach that NAT gateway and then we can proceed with the VPC endpoint tasks. So let's do that real quick. I'll go to my VPC, I'll go to NAT gateway and click on create NAT gateway. We can name it as demo NAT gateway. We'll be choosing the public subnet as private subnet cannot be used as the assigning of the NAT gateway, as NAT gateway needs to be assigned to the public subnet only. So we'll be choosing the public subnet for the assignment of the NAT gateway. We'll be choosing the connectivity type as public, and we'll need to assign an elastic IP over here. And everything looks perfect. Click on NAT gateway. We'll be creating NAT gateway, and so our NAT gateway is in progress. As you can see, that state is in pending, and once it's created we'll be attaching it to the private route table. So let me go to my route table over here and go to private route table, go to routes, and we'll edit the route and click on and use the destination as internet, as we need the internet access. And I'll go and choose the internet gateway. No, not that one. We'll be choosing the NAT gateway, and the NAT gateway name is demo NAT gateway. I'll be choosing that one and click on save. This simply means that anything that comes using this NAT gateway will be routed to the internet. Any EC2 instances or any RDS instances associated within this subnets, private subnets, will be routed to the internet using this NAT gateway. So we have done that, and let's see if our NAT gateway is up and running or not. And we can see that the status of the NAT gateway has been changed from pending to available. And now if we go to our server and click on sudo apt update, and you can see that I'm connected to the internet and I'm successfully updating my server. Now that is working perfectly. So this is the main difference. So using the NAT gateway, we are just pinging to the internet and our request is just getting through the public internet. So we'll be installing the AWS CLI that is we'll be needing while configuring the AWS for performing the RDS related actions. So the command for installing the AWS CLI was sudo apt install AWS CLI. We'll be clicking on yes, and within few minutes only it will be installed. Okay, so the installation has been completed. Let's from the AWS configure. First we can check if our server is available to the internet or not, or we can say we are able to ping to the public internet through our private EC2 instance. And we can see that we are able to ping to the Google server. That simply means that using the NAT gateway we are able to connect to the public internet using the private subnet hosted EC2 instances. So this is the scenario, and we don't want this to be happening at our end. So I'll cancel this and delete the NAT gateway. So I'll be clicking on actions. I'll click on delete NAT gateway. And we can see the status of our NAT gateway is deleting. Let me go to the route table and deattach the route table, NAT gateway route table from the private route table also. I'll click on edit, and as it's saying that it's been in the deleting state, so the status has changed from active to black hole. I'll simply click on remove and save changes. And if I clear my screen and click on ping, and we can see that now we are not able to ping to the internet. This simply means that we are not able to ping to the internet. And let's cancel it, because hopefully it will just cancel in few minutes automatically. I'll clear my screen, and yes, now let's try to hit a API gateway. So these are the commands that we'll be testing with. So let's first see what are the steps that we have completed. So we have created the VPC and the contents inside it. We have created EC2, we have created VPC endpoints, and yes, the VPC endpoint creation is still pending. So let's test few scenarios right now. So let's go and test for this, and let's create a database using this command. I'll copy this one and paste it over here. This simply means that using this RDS database related command, we will be creating a database, and the database instance identifier name will be this one, and the database instance class will be of db33 micro. Engine will be of our MySQL database, master username, password, allocated storage space, and these are the parameters that we'll be using while creating the AWS RDS instance. So I'll be clicking on enter, and if I click on enter, it says that you can also configure your region using AWS configure. So previously we haven't done that, so let's do that. We'll be clicking on sudo AWS configure, and yeah, in this place we'll be needing to push the AWS SSK and secret SSK that we have generated previously through the IAM user. So we'll be opening that one and copying the SSK and pasting it over here. Enter, it will be asking for me the secret SSK. I'll be copying that one also from this sheet only, and paste it over here. And now it says that we need to populate the default region name. So the default region that we are currently working on, all of the resources are created in the North Virginia region that is associated with US East 1 region. So we'll be typing that one. So we'll click on US East 1, click on enter, and I'll leave it as default and click on enter. So we have successfully configured our private EC2 instance with the required roles to access the AWS RDS service from it. Now if I hit the same command again, as we do not have the internet access, so it will most probably return us the error that says that could not connect to the endpoint URL, that is https rds east1a amazon aws.com. So this is the endpoint or URL that needs to be accessed. So in our case, the EC2 instance is not reachable to the public internet. Thus, we are not able to access this URL or the service present in this URL. So what we can do in this case, we will be using the VPC endpoint. So as described previously also, that VPC endpoint provides us the gateway to connect to the AWS services without using the internet gateway or NAT gateway or using the public internet. So without going to the without using the public internet or external internet, we can connect to the AWS services internally using the AWS network only, using the VPC endpoints. So let's create the VPC endpoint once and let's see if we are able to perform this action or not. So let's do and create VPC endpoint. So I'll be going to the, okay, it's present over in the virtual private cloud section. I'll click on the endpoints and I'll click on create endpoint, and as we can see that there are multiple AWS services. To access them, we can use these endpoints. So there is Athena, there is AWS connector, there is CloudTrail, there is code build, there are a lot of services. In most of the services, as you can see there, the type is interface type. That simply means that this type of VPC endpoints uses elastic network interfaces as its gateway to connect to the services present in the AWS. As we are doing this demonstration for the RDS one, so I'll click on RDS, click on enter, and we can see there are two services, that is US East1a.rds and US East1.rds/data. This is simply meant for the AWS Aurora service that will be looking further into other sort of videos. Thus we'll be choosing this one that is meant for the MySQL or other databases present in AWS services. So we'll be choosing that one, and for the VPC I'll be choosing the custom VPC that I have created, that is demo VPC, and the availability zones that were associated with custom VPC were US East 1 and US East 1B. And as we are meant to create our private EC2 instance is being associated with the private subnets, we'll be selecting the private subnets only, that is private subnet 1 and private subnet 2. That looks perfect. We'll be enabling DNS name for this, so it's based on your option or based on your requirement. I'll be selecting the default one was enabled, so I'll be selecting that one. And the best part is that we can just select or we can create an EC2 instance security group for the VPC endpoint also. So there is a double layer of security. So let's create a new security group for our VPC endpoint. So let's name it as VPC Endpoint SG, and the VPC that I want to associate this security group is demo VPC. I will click on add inbound and I will select the HTTPS because this is the port or this is the port range that VPC endpoint will be using to connect with the EC2 instances for calling the API calls. So this is the port that needs to be mandatorily opened for the VPC security group. And for the custom, for now will be choosing anywhere, and I'll click on save. And that is create a security group. Okay, let me give it a name for VPC endpoints and click on create security group. Okay, our security group has been created, and yes, for the security group that we have previously created, that has been reflected over here, that is VPC Endpoint SG. I will be selecting that one. And another best security option that VPC endpoints provide is the a policy. So for now, we'll be selecting the policy as full SS. That is, this full SS policy will be applied to actions that we perform on the private EC2 instance. Any of the actions that we create or perform will be provided a full SS. That simply means that any actions will be permitted. And for tags, I'll leave it as default for now and click on create endpoint. And my VPC endpoint has been created successfully. And I'll click on close, and I can see that the status of my VPC endpoint is in pending state. Let me give it a name. Give it a beautiful name. What can be it? Let me give it a name, demo VPC endpoint. Okay, and it's in the state of pending. Okay, so the status of my VPC endpoint has been changed from pending to status. That simply means that our VPC endpoint is ready to be used. And let's go and hit the same URL that we were before trying to access and was not being connected, as we are not having the internet access. Let's see if it works once we have enabled the VPC endpoint or not. Let me click that one once again and click on enter. And we can see that the output of the above command that says that the RDS instance has been created. So we can see all the details has been populated over here that is related to the command that we have pushed above, and it has successfully worked. So let's check at the RDS int if the RDS instance that we have mentioned in the command has been created or not. So let me go to the RDS service once. We can see that a new RDS instance has been created as is in the creating state. This simply means that the VPC endpoint that we have created for the RDS is working perfectly as per our requirement. So let's go back to the CLI. So as in the CLI, we can see the output of the above command, and we can see different outputs related to it. So the main outputs can be seen over here. That is, the allocated storage is 5 GB and the DB instance status is being created. The database instance class is this one, and these are the subnets that are associated with the RDS instance that has been created. So yes, and now let's double check if we are connected to the internet or not. Let's ping 8.8.8, that is Google server, and click on enter, and we can see that we are not able to ping to the Google server. That simply means we are not connected to the public internet. Then also we are able to connect or hit the RDS related APIs. That is because we have created the VPC endpoint for it, and we are inside the AWS network, and we are securely just pushing the API calls for the RDS, that is creating RDS instances, and we can modify the RDS instances and even just perform other RDS related API calls. So that is pretty much of cool, and we can see that the RDS instance has changed its status from creating to available. And let's click inside it and check that the storage of it is 5 GB. Now let's go to the CLI, and yes, here over there we can see that it's still not pinging to the internet. I'll cancel it and I'll use the okay, let me clear my screen and hit this command. Okay, this command simply means that we are changing the allocated storage from 5 GB to 10 GB. This simply means that we are modifying the existing database that we have created from the command before. Let's click on enter, and yes, the output has came. This simply means that it's a positive result and our changes has been reflected. So let's go to RDS in the AWS management console and go to databases, and you can see that the status of my RDS database is being changed from available to modifying. This simply means that our API call for modifying the RDS database is also working perfectly. And yes, if I go inside my database and if I see, I'll go to configurations. Currently my storage is 5 GB, and once the modification is completed, storage will change from 5 GB to 10 GB. Still our RDS database modification of the storage in progress. Let's see the two major aspects of the VPC endpoint. So we'll go to the VPC, we'll go to endpoints. And this is the endpoint that we have previously created. And the two major things that I want to talk about is the security group and the policy. So let's first talk about the security group, as we have explained previously also. So the security group is being implemented in the VPC endpoint so that there is a double layer of security. And if we see the inbound rule of it, the inbound rule that is opened is only for the port 443, and the source is open to all. And we can use the security group of this VPC endpoint as a source in the security group of the private EC2 instance. So let's see what we can do at the private EC2 instance. Let me go to the EC2 instance, and if we go to the security group of the private EC2 instance, go to security and open its security group, and edit the inbound rule. The SSH port is open to all, but we can just click on my IP so that I'm only able to SSH into the server. And for the port 443, we can provide the security group of the VPC endpoint as the source, so that this private EC2 instance only accepts the traffic triggered from the VPC endpoint on the port 443 only. And we have done that already, so we'll not make any sort of changes. If in your end, you can just implement this scenario that the security works at its best on your end. So we'll be cancelling that one. And another most important aspect that I want to discuss is the policy. So previously we have selected the full access that allows access to all the services in the AWS by any user. But at the security level, we may not want to implement the full access. So we'll be clicking on edit policy. And instead of choosing the full access option, we can choose the custom option, and we can just write our own policy. So let's test it out. So I have a policy already created at my end. I'll copy this one and paste it over here. So this policy simply means that it will allow only the create database instance API call from the VPC endpoint that we are attaching this policy. And any other API calls, such as deleting the database instance or describing the database instance, would not be permitted or would not be allowed. So it will be only allowing us to create DB instances. So let's save it. And now if we try to hit the command or API call to delete the RDS instance, then it must not work, because we haven't allowed that into the policy that we have attached. So let's try that one. Click and paste. It simply says that we'll be deleting the database instance with the name MyDemoMySQL instance. This is the name of the database instance, and we'll skip the final snapshot. I'll click on enter. And if I click on enter, it says that the demo VPC endpoint user is not authorized to perform this delete DB instance operation or API call. So the policy that we have updated, that is this one, that only allows us to create the database instance and does not allow us to perform any other actions, has worked perfectly. And similarly, in the policy, we can just update any sort of policies as per our requirement and just use the VPC accordingly. So perfect. And also we can see that the modification of the RDS instance has also been completed. Let's go inside it and see in the configuration section, as the storage has changed from 5 GB to 10 GB. So the modification API call has been also working perfectly. Okay, so we are talking about the policy. Let's go over there. And in the policy, currently we have create database instance policy. Let's modify that one and add a bit of line. Looks perfect. I'll save it. And we can see that the policy of ours VPC points has been updated with two policies to allow them. One is to create DB instance, one other is to delete the DB instance. So let's go to the CLI. And previously it was not giving us the permission or the user that we have assigned is not authorized to perform the delete div instance operation. Let's try that once and click on enter. And once I click on enter, it shows the output as this sort of JSON format output. That simply means that our database has been deleted successfully. Let's verify that by going to the AWS Management Console of RDS. And currently we can see that the status is available. If I refresh my page, yeah, the status has changed from available to deleting. This simply means that our policy has worked perfectly. So we have now came to the end of this demonstration. So now let's finally summarize what we have done till now. So we have created a VPC. We have created a VPC with CIDR block this, and we have created 2 private and 2 public subnets. We have created route table. We have created 1 internet gateway and attached it to the public route table. We have created 2 EC2 instances, and one as the bastion host and one as the private EC2 instance, from where we just called to the RDS API calls using the VPC endpoint. And finally we created the VPC endpoint, and using that VPC endpoint we were able to call the RDS related API calls without going to the internet. We also looked into how to use security group and policy in VPC endpoint effectively. So thank you everyone for being with me. Hope this video session was helpful at your ends. In case if you have any queries related to this, do make me know at the comment sections. Would love to help. Thank you. We'll meet soon.